Our second step in right triangle trigonometry is going to be using our trigonometric ratios to find missing sides in a right triangle. We're going to try to get through this pretty quick here. Again, you've done this before. So there are three steps we're going to use to finding the sides of a right triangle. First thing you always have to do is look at your triangle and recognize what you have. We have to recognize the information that's given to us and decide which ratio can we use. Once we've selected our ratio, we then will write an equation using our ratio, and to finish the problem, to get to our solution, we'll solve the equation. So those three steps we will follow all the time. So let's go ahead and look at our first example here. We look at our information that's given to us. We have an angle and two sides that we're working with. We know one side, we're missing the other. So when I look here, from my angle, that's always our critical starting point. We go from the angle and see what information do we have. We have an x and an 8, and that x is next to the 65-degree angle and not the hypotenuse, so that means it's adjacent. And 8, we have hypotenuse, so that tells us we have to use cosine, because cosine is the ratio of the adjacent side to the hypotenuse. That's the most difficult step for people that don't understand trigonometry, is recognizing which ratio to use. You look at the information given to you and use that to write an equation that goes like this. We always take the trigonometric ratio, or the cosine in this case, of our angle is equal to its fraction that's associated with cosine, the adjacent side over the hypotenuse. So we've done step 1, we recognized our ratio. We've done step 2, we've written our equation. Step 3 is to solve our equation. If we want x by itself and we have x over 8, I'm going to multiply both sides by 8. So x is 8 times the cosine of 65, and that cosine of 65 is a number. It's a constant value, and it's a constant value that is always going to be less than 1. Because we have this adjacent over hypotenuse, the hypotenuse is always the longest side, so therefore that fraction is always going to equal a value less than 1. So I take out my calculator and I do 8 times the cosine of 65, and that gives the solution. X is 3.4. That would be our missing side, x. This is how we use trigonometry to find a missing side. We set up our ratio, solve the equation, and end up with the value for our missing side, where x is 3.4. So let's look at one more example that sets up a little bit differently. In this problem, we're looking for side y. In order to find y, we begin by identifying our ratio. Y is the adjacent side, 12 is the opposite. If I'm using opposite and adjacent, that tells me it must be tangent. What we have decides what ratio we're going to use. So I set up my equation. The tangent of the angle is equal to the ratio of the opposite side to the adjacent side. And the work we're going to do here gets a little bit long, and I'm going to show you a shortcut in the end. But we need to see why the shortcut works first. I always want to get rid of the fraction. So that makes y times tangent of 32 equals 12. To get y by itself, I have to divide by tan 32. Getting us y equals 12 divided by the tangent of 32. That becomes a calculator problem. And our calculator tells us the answer is 19.2 for side y. That gives us our solution. However, that's a lot of work for this single problem situation, when if we look back at what the original problem had, and what our solution was, we can recognize a shortcut here. That whenever the variable is on bottom in our ratio, what happens is our y and our tangent 32 traded places. If you look down here, you have y tangent 32, tangent 32 y. They traded places in the problem. That's what the algebra does. When we do the work for that, the algebra makes those trade places. So if you want to use that as a shortcut, you're more than welcome to. Anytime the variable ends up on bottom, your solving steps are going to lead to you punching in the calculator 12 divided by the tangent of 32. All right, if you have problems finding sides, please make sure you're asking questions during class, and good luck.